Hi everyone, welcome to geometry class. Today we're going to be in chapter 1, section 3 of our textbook, talking about measuring angles. So grab your textbook, turn to page 20, and follow along with your notes. When you find formulas and examples, please write them down in your notes. So today in this video, you'll be able to answer the following questions. What is an angle and how do you name an angle? What are the different angle types? How do you add two angles together? And how do you find the measure of two congruent angles? So let's start with a pizza. Let's say you and your friends are trying to share a pizza and you're trying to tell them how big of a slice you would like. Well, since slices come in different sizes, you want to be really specific about how big you want your slice. One way we can do this is use an angle to describe how big you want your slice. So an angle looks like this. An angle is a figure that's formed by two rays, or sides, that share a common endpoint, or a vertex. So in this angle we have ray BC and ray BD, and the endpoint that both rays share, or the vertex, is vertex B. So we have a couple of options on how to name an angle. We can name an angle when it's by itself, by its vertex. In this case, this would be angle B. We can name an angle based on the point on each ray and the vertex. We always name the vertex in the middle. It's the middle letter. So this is angle CBD or angle DBC in either direction. Or we could also name it by a number. In this case, this is angle number 1. We use this notation, this symbol, to name an angle, always before the name. Okay, so the interior of an angle contains all points between two sides of the angle. So here is the interior of our angle, angle B. And the exterior of an angle is all points that are outside of the angle. Let's talk about how we measure an angle. If we start with a circle, or in this case, a pizza, we know that a circle measures 360 degrees. So we use degrees to measure a circle. Well, since an angle is a piece of a circle, in this case, then we can also use degrees to measure an angle. Now, degrees for an angle really is a measure of how far apart the two rays are, the degree of openness between the two rays. Okay, so there are a couple of different angle types we'll be looking at today. The first one we're going to look at is an acute angle. An acute angle measures greater than 0 degrees and less than 90 degrees. So if x is our angle measure, it's greater than 0 and less than 90. And here is a picture of an acute angle. The next type of angle we're going to look at is the right angle, and it measures exactly 90 degrees. We use this perpendicular symbol to say that this angle is 90 degrees. An obtuse angle measures greater than 90 degrees, but less than 180 degrees. So here is an example of an obtuse angle. And then finally, a straight angle measures exactly 180 degrees. And it's formed by two opposite rays, which we've learned, and it forms a line. So let's say your friend has one slice of pizza, and you have another slice of pizza. And you want to see how big of a slice you would have if you put the two slices together. So we can represent this by really just putting two angles together. So the first angle we have here is angle CBD. Now I can't name this angle just based off its vertex anymore because I have two angles that share the same vertex. So the options for naming this angle is angle CBD, DBC, or angle 1. The next angle we have is angle DBE, angle EBD, or angle 2. And together they make the larger angle, angle CBE, or angle EBC. Great. So the measure of angle CBD, I have as M in front of the name of the angle, it means measure, and that we'll replace that with a degree of the actual angle. The measure of angle CBD and the measure of angle DBE together, when you add them, equals the larger angle, angle CBE. That makes sense. So let's put some actual values to the angles. If angle CBD is 50 degrees and angle DBE is 30 degrees, then I can plug in those degrees for each measure of the angle, and together they would give me 80 degrees for the larger angle CBE. Okay, this idea is called the angle addition postulate. So right now I'd like you to pause the video and write down the angle addition postulate using this example. So let's use the angle addition postulate to solve a problem. So we still have angle CBD, DBE, and the larger angle, angle CBE. But instead of actual values for these two angles, I'm going to give you an expression representing the measure of each of these angles. So what we want to do is find the measure of angle CBD and the measure of angle DBE, the two smaller angles. Okay, we can use the angle addition postulate to solve this problem. Now what our first step is to find a relationship between all of the angles. We've already said that the measure of angle CBD plus the measure of angle DBE equals the larger angle measure of CBE. Okay, this is always your first step. The next step, we can plug in the values, or the expressions in this case, with variable x for the measure of each angle. We know that this is 10x, this is 6x, and the entire angle CB is 80 degrees. Okay, so now let's solve for x. Our next step is to combine like terms on the left-hand side of the equation, set it equal to 80 degrees still. Then let's try to isolate the variable x by dividing by 16 on both sides. When we simplify, we get x equals 5. But we can't stop here because remember, we want to find the measure of both of these angles. So we're going to plug 5 back in to each of the expressions. So the measure of CBD is 50 degrees when I plug 5 into the expression. And the measure of DBE, this angle, is 30 degrees when I plug 5 in to this expression. So together, the measure of angle CBD is 50, and the measure of angle DBE is 30. When we add these together, they equal 80. So remember always to check your work to make sure it checks out, and in this case it does. So we've used the angle addition postulate to solve for the measure of both of these angles. Okay, so what if you and your friend had two equal slices of pizza? Well, we can represent these pieces of pizza as angles, and since the slices are the same, are equal, we can say that these angles are congruent. We can tell that angles are congruent by using these markings called arc marks. So the arc marks tell us that the measure of angle ABC is equal to the measure of angle DEF, and also that the angle ABC is congruent to angle DEF. Remember, congruent means the same size. So when you see angles with arc marks, you can only conclude that the angles are congruent if they have the same number of arc marks. So in this case, these two angles have the same number of arc marks, so we can say they are congruent. And these two angles have the same number of arc marks, so we can say they are congruent. But if they do not have the same number of arc marks, they are not going to be congruent. Okay. So let's lastly look at if you and your friend have one slice of pizza left in the pizza box and you both are equally hungry, you'd probably want to split your last piece of pizza exactly in half. Okay, so if we represent the pizza as an angle again, we want to cut the angle exactly in half. And we do that by using an angle bisector. Remember, to bisect means to cut in half. And so an angle bisector cuts an angle in half. Specifically, it's a ray that shares the vertex with the angle. So here's the endpoint of the ray, and it extends into the interior of the angle. So in this case, ray BD bisects angle ABC. It cuts in half. So the two smaller angles that are formed are congruent. Okay, so let's solve a problem using the idea of an angle bisector. In this problem, we still know that ray BD bisects angle ABC. So because it bisects it, we know that angle ABD is congruent to angle DBC, which we're showing here using the arc marks. Okay, so the measure of angle ABD I'm giving you as an expression with variable x, as well as the measure of CBD. Okay, so the first step in this type of problem is to always find a relationship between the angle measures. Because we know that ABD the measure of angle ABD is equal to the measure of CBD, I can set them equal to each other. We know that because of the bisector BD and the arc marks. Okay, the next step is just to plug the expressions in for the measures of each angle, which we've done here in step 2. Now I'm going to collect all of the x's on the same side of the equation by subtracting 2x on both sides. And after simplifying, we get 3x equals 15. Our last step is to isolate the variable x by dividing by 3, and we get x equals 5. But again, we want to find what the measure of angle ABD is and the measure of angle CBD. So after plugging in x to each expression, we get the measure of angle ABD is 25, and the measure of angle CBD is 25 as well, which is what we expected because the two angles are congruent or equal to each other. Great, guys. So you've just used the idea of an angle bisector to solve for the measure of each angle. So in review, you've learned what an angle is and how to name an angle. You've learned the different types of angles. You've learned what the angle addition postulate is and how to apply that postulate. And you've learned what an angle bisector is, how it cuts an angle in half, and how to apply it in solving a problem. Great work today, guys.